This video will explore the role of algorithms, which are essentially step-by-step instructions. We will look at examples like a recipe, a card trick that involves a setup and a repeating loop, and Euclid's algorithm for finding the greatest common divisor. In plain terms, an algorithm is a set of steps defining how a task is performed. Like a recipe, the intelligence is built into the steps. The person or machine executing the steps doesn't need to understand the underlying principles, they just need to follow the directions. We can see algorithms outside of pure math, like in a card trick. The cleverness is in the setup, where you sort and bend the red and black cards slightly differently. This creates a physical tell that the performer simply follows during the trick. The card trick is structured as a loop. After the one-time setup, the performer repeats the steps of asking, checking the card bend, and revealing the card until all cards are gone. This is the structure of many algorithms, a setup followed by a loop that repeats until a stopping condition is met. Euclidean algorithm is a mathematical procedure to find the greatest common divisor of two integers. It involves repeatedly dividing the larger number by the smaller number and replacing the larger with the remainder until the remainder is zero. The last non-zero divisor is the GCD. Here is the Euclidean algorithm flow, visualized as a loop. We start by assigning the larger and smaller numbers. Then we divide and check the remainder. If the remainder is not zero, we update the numbers and loop back to the division step. If it is zero, we are done, and n is the GCD. Even powerful algorithms have limits. Gödel's incompleteness theorem shows that in sufficiently complex systems, some true statements cannot be proven by algorithmic means. Algorithms are powerful, but they are not all-powerful. To summarize, algorithms are step-by-step instructions where the intelligence is in the steps, not the executor. Many algorithms use a setup followed by a repeat loop. Crucially, as shown by Gödel, algorithms have a permanent "speed limit," meaning some truths can never be reached by any algorithm.